In this video, we're going to be going over how to create a profile for your proposed alignment to mirror the existing mainline track. Um, so for this one, you're gonna need a point file, and um, you're obviously gonna need your proposed alignment, and you're gonna need a feature line or something of your low rail for the main line. In case you don't have that, I can just show you how to create one really quick. So I've actually gone ahead and created one, but all you're doing is figuring out which two sets of points have the lower elevation value. So in this case, usually it's the inside of the curve, so all you got to do is create a polyline, turn on your snap to node, and just click along like this. And yeah, and then if it starts transitioning to the other side, you just simply just go to the other side like this. And that's pretty straightforward. I've already created a polyline like that for this side in order to make this into a feature line with elevation. So you're going to have to first create a new surface of the top of rail. So I'm going to create a really quick one here. I'm going to call it top of rail surface. For this one, I'll actually just turn on triangles if we have it here. Contours and triangles, sure, that'll work. Yeah, let's do that. And on here, I'm going to add the point, oh, not a point file, but a point group. I'll add the top of rail point group. And we get this. I wouldn't worry too much about this surface. It's just for creating um, our feature line. So you can leave it as is, but I'm just going to delete some of these lines so that it doesn't look so crazy. Okay, so now we got a simple top of rail surface. So this surface will just tell us um, where the rail is. But the reason we created that is because we want to extract elevations to our feature line. So we'll go ahead and create a feature line here. Create feature line from object. Since we've selected it, we don't have to select it again. Now I'm going to call this low rail. And then we want to hit assign elevations, and here we want to assign elevations from surface, top of rail surface that we just created. We don't want intermediate grade breaks or anything like that. We'll hit OK. Now that turned it into a feature line, and if we go to the elevation editor, you can see it took the points. It took the elevations from the surface. Um, yeah, that's it. I'm going to actually just change the style so that it's a different color. Or actually, let me just change it to a different layer. Yeah, let's make it blue so that's easier to see. Okay, so we got that. Now we're going to be creating a profile for this track, and we're going to superimpose this in there so we can figure out where our low rail is. So let's first create the profile. So I'm going to select the proposed siding track. We don't need this surface that we created, but let's go here. There we go. Now I'm going to project objects, and I'm going to select this one. And it says select objects. Okay. And then you can select a style if you want, but I think I'll just keep it as the basic one. And there we go. We got a basic existing mainline top low rail profile. Now this is not a smart profile, it's just kind of lines. It's a feature line. We want to turn this into an actual profile with vertical curves and everything. So to help ourselves a little bit, we're going to just change this so that we can see both viewports at once. So we're going to go here. Now you can see when I'm hovering over this, I could see where I'm at. It's really helpful when you're doing plan profiles like this. And that's done through here, station tracker, all viewports. Okay, so now we want to create our vertical tangent lines. And it's very similar to how we created the best fit line. So we're going to do this, but instead of picking Kogo points, we're actually going to be clicking on the screen. And how we do this is instead of node, we'll go to endpoint and you'll see that every single vertex. So if you look at our points, right? If you look at every single vertex on our feature line, it lines exactly up with our set of points. So this basically acts as like a best fit profile. So we can do this. Um, we'll just click as many points as we can until we kind of notice a curve coming up. So we can see there's a bit of a change here, but we're going to keep going with this. All right, maybe we can stop there. All right, let's see. So unlike when we did a best fit alignment, we don't have 2 points, we have 1. So we're trying to get to 0. So we can exclude these points with like massive offsets. Um, we'll follow similar methodology. We're going to try to go to under 0.05 or less actually for profiles. Now you should remember, or I should note that this profile has a vertical exaggeration of 10, so this isn't actually as bad as it seems. But this looks pretty good. Yeah, let's try that. Okay. So you can see now that actually this looks like it's on a curve, so we might have to move this turnout further because obviously a turnout can't be on curve. But we don't have enough. I mean, I guess we gotta go further back to figure out where this vertical curve is. But let's just keep going forward with this. So let's do another one. We'll do from screen. And we're just gonna pick points like this. So it's not gonna be perfect. There's lots of kinks and stuff that happens over time due to lack of maintenance or other variables. But actually for this one, yeah, let's send it here. So once again, we're just excluding points from either end until we get a reasonable offset. Let's eliminate this. Now we're getting somewhere. Okay, let's actually turn that one back on. This is pretty good. Let's do that. So this looks like there's multiple curves here. Let's keep going. Let's do this. Okay, let's exclude that point, and we're good. So there's definitely several curves in this area. So we want to just extend these tangents to figure out our PIs. So we can once again do the fillet command. Oh, let me just extend this. Oh, that's interesting. Hmm. Let's create a couple more best fits here. Wrong option. Let's click that. A lot of this is really trial and error until you get something that works. Let's do that. Like sometimes something looks like a tangent, but it's actually not. Um, there is quite a bit of interpretation in this, so let's let's ignore this one and let's just extend this. So this might be one entire tangent, and this might be the curve here. It's probably a curve or a vertical PI here. Yeah. Now, when you're going in to create your profile, it's very simple. You just, go here and you create profile tools, and you can say propose siding proper rail, something like that. Sure, let's turn on a label set. Now, once again, you do this. So let's start from here. We can always adjust this later. Select our intersection points like that, and then we'll go up to here. There we go. So now we have two options. We can just enter in, actually, yeah, I like to just enter in the vertical curve radius now, or curve length. So we can do vertical curve parabola, and we'll set incoming, outgoing, and then for curve radius, it's about, um, you got to do a calculation based on your train speed to figure out your minimum vertical curve. But for this one, let's just use 60 meters, something like that. That looks fine. And we'll do that here as well. Oh, I think I selected the wrong. Let's go like this, click that one, click this one, 60 meters. There you go. So we're essentially matching the existing track and creating our new profile so that they're exactly level. Sometimes your design requirements might say that your new track must be lower than the existing, and to do that, all you have to do is, so you select your tangents and you just lower it by whatever value you need. So if you want to make this 2 inches lower, or 50 millimeters, you just go 0.5 like this, because remember it's 10 to 1 vertical exaggeration. Your PIs will essentially change. Your new vertical PI would be somewhere out here. Your new vertical PI would be here, and you just adjust the curves to match. Yeah, and that's basically how you create a vertical profile. Thanks for watching. Bye.